So, dear students, welcome back again to this class. Today I am going to take up a problem on your projection of solids, in which I will take up two cases. So, first case will be your hexagonal prism. You have a hexagonal prism, and another case is your square pyramid. Square pyramid. So, once we understand the hexagonal prism, then we can have your cylinder that can be understood on similar lines, and similarly in case of your square pyramid, I can take up your case of your cone. So, they belong to one family and other belong to the other family. So, I am going to take the problem of hexagonal prism first. You write down the problem, I will read the problem. So, the problem can be that a hexagonal prism with edge of the base 20 mm and axis 50 mm long has one of its surfaces inclined at 45 degree to VP, and one of its longer edges rests on the ground. Draw the projections of the prism. So, now here we have a case in which we have the hexagonal prism. So, I am going to draw the problem. So, I have the hexagonal prism, so that rests on the ground in such a way that its axis is inclined at 45 degree to the vertical plane. So, how I will proceed with the problem? First of all, we will draw the hexagon of 25 mm side each. So, it rests on one of the. So, we have the problem in which you have the hexagonal prism with edge of the base 25 mm such that it rests on the ground. So, the first step is to decide what type of hexagonal it will be, whether it will be a corner type or edge type. So, this as per the problem you have the edge type of hexagon. So, I will draw the hexagon. Now, I will name it. So, A, B, C, D, E and you have your F. So, it is a case of your prism. It means top surface and bottom surface will be your hexagon, because it is a hexagonal prism. So, now since it is front view, so we will name it as A dash, B dash, C dash, D dash, E dash and F dash. Similarly, its lower surface, that is this one. So, we can have it as 1 dash, B dash and then 2 dash, C dash and then 3 dash, D dash and then 4 dash, E dash and 5 dash, F dash and 6 dash. So, now what we will do? We will draw its top view. So, top view will be a rectangle. So, you have to use pencils in such a way that projection line should be light or as light as possible. So, now the axis height is, so edge of base is your 25 mm and axis is 50 mm. So, this is the basic information about the hexagonal prism, such that A, B, B, C, C, D, D, E, F are all 25 mm. And now we have to locate the axis height. So, for axis height, we will name it. First the top surface. So, you have your A and B, you have your D and E. What about this C, and this will be your F. Similarly, bottom 1, 2, 4, 5 and this one will be 3 and this one will be 6. Now, axis will be this CF, C and F. So, generally axis should be dash dot dash dot dash dot dash dot dash dot dash, something like this, dash dot dash dot dash dot. Now, how to see it from the top? If you are able to, if you want to see its top view, so how will it be top view? First of all, we should know what will be the axis length. So, CF and 3x, I can say this will be the axis, CF and CF, or we can say C3 and 6F, this is the axis. So, this length is your 50 mm, this length is your 50 mm. So, CF and 36, or I can say C3 and F6 is the line which is called axis, and this line basically divides the solid into two equal halves. So, this is your prism. So, prism, you have the top surface and the bottom surface or the lower surface, top surface, bottom surface, hexagon. You know how to draw the regular hexagon, which I have explained in the previous classes during the projection of your planes, that how to draw the regular objects. So, now the problem says that which one should be continuous, which one should be hidden. So, that is the basic objective of recording this video. What will be continuous, what will be hidden. So, if we see from the top, we are able to see 2 and B, yes. We are able to see 3 and C, yes. We are able to see D and 4, yes. But what about this A and 1? Are we able to see from top? No. Why? Because you have B, you have 2, but B is overlapped, this A is overlapped by B, similarly 1 is overlapped by 2. Similarly, this 6 and F, they are overlapped by 3 and C. Similarly, this 5 and E, they are overlapped by 4 and D. So, now what the logic in case of your projection of solid is that the points which are nearer to xy, so this is xy plane, the xy line, the points which are nearer to xy. So, what are nearer to xy? A1, F6 and E5. So, they are nearer to xy. So, when the points which are nearer to xy, when we are able to view them, they will always be hidden because we cannot see them clearly. But on the other side, you have the points B2, C3 and D4, they are clearly visible. So, always remember, when a clearly visible point is superimposing or overlapping your hidden point, then we always have to show it as a continuous. It means any hidden object, hidden is generally like this, dash 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 dash. So, whenever a continuous point overlaps or superimposes your hidden part, it becomes your continuous. So, it will be your continuous. So, this is the logic. Otherwise, the points which are nearer to xy, they will always be hidden. They will always be hidden. Now, the problem says the axis of this particular hexagon makes an angle of, that is inclination to vertical plane is some 45 degrees. So, what is the axis? The axis is C and F. Here, though we have your C as continuous, but since it is an axis line, so we are showing it as dash dot dash dot dash dot, because we have to show different parts of the solid, and axis is a very important part of the solid, or means this is the prism. So, it will be CF and 3, 6. Now, what we will do? We will change the orientation of this hexagon in the vertical plane such that the axis CF, it is inclined at 45 degree to the vertical plane. So, what we will do? We will take the same rectangle and we will reproduce it in such a way that the axis, that is CF and 3, 6, they are inclined at an angle of 45 degree to the vertical plane. So, I will draw something like this. Now, how to do it? Suppose A, B, C, F, D, E. So, this point will be your A, B, this will be C and F, and this will be D and E. or dash dot dash dot dash dot dash dot dash dot dash. So this will be your 3 and 6, 4 and 5, 1 and 2. Now how to do it? You draw a line that is at an angle, whatever angle is there, that is angle phi. So 45 degrees. So this is your angle phi. So what you have done? You have inclined this axis CF and 3, 6 at an angle of 45 degree to the vertical plane, and then you mark the distance from A to B, whatever distance is there, A to B this, and then from C to F DE, C to F DE. Similarly, you draw the parallel lines, and then we can reproduce it. Or how we can proceed? You draw any line at an angle of 45 degrees. Mark this length CF, and then once the CF is marked, you have to transfer the distances from CF, whatever distance AB is there, CF AB distance is there, you cut an arc here. Similarly, from CF, whatever distance D is there, you cut an arc here, and then complete this AB, CD, EF. On similar lines, you can have 4, 5, you can have 1, 2. So this way, I have regenerated this rectangular box, that is prism, such that its axis makes an angle of 45 degree. Now what I will do? I will draw the locus. So F dash 6 dash, A dash 1 dash, E dash 5 dash, 2 dash B dash, D dash 4 dash, C dash 3 dash, and C dash 3 dash. Yes. Now what I will do? I have to project its front view. So for front view, what I will do? I will see which one is clearly visible and which one is not visible. So whether 1 to 2 is visible? Yes. 3 to 6 visible? Yes. 4 to 5 clearly visible? Yes. Why? Because we are seeing it from the top. But what about this AB, CF? Are they visible? Since they are closer to XY, so they won't be clearly visible. So now I am going to draw its projectors. 1 dash 3, 6, 4, 5. ठीक है. तो सबसे पहले 1, 2, 3, 4, 5, 6 को लोकेट करेंगे. 6 कहाँ पे आ जाएगा? ये आ गया 6. 1, 2 ये आ गया आपका 1, 2. ये कैसे आएगा? Intersection of projector and locus. Whatever point that we get, then we will locate those points. 2. So this is your 2. 6, 3. So this point will be your 3. 4 and 5. Is it 6? 6, 5. So this is your 5 and 4. Or you can remember this way, that 2 and 4 will lie on same projector, 1 and 5 will lie on same projector, 3 and 6 will lie on same projector. So whether 1, 2, 3, 4, 5, 6 are continuous? Yes. So first of all we will join it. So 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, and then 6 to 1 or 1 to 6. So this is 1. Now let us talk about AB, CF and DE. So AB, so this is the locus of A and B. This point is your A. B, this point is your B. Now I will draw the projector from here, C and F, D and E. So C and F. So this point will be your F. What about C? So this point will be your C. D and E. So this point will be F. This point will be E. and D, yes, this one will be D. Or in other sense, what you can say, A and E will have the same projector, yes, A and E, same projector or same locus, B and D, B and D, C is all alone single, and F is all alone single. So now we have to generate the other view. So D and E, so whether D and E are visible, yes, from here if we see, yes, D and E. So I'll write join here directly. C to D, C to D, C to D. Whether you are able to see C, no. So let us say we will show it as hidden. So any hidden is dash 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 dash. Always remember there is a difference between hidden dash 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 and axis line dash dot dash dot dash dot dash dot dash dot. So there is a difference between hidden line and axis line. This is your hidden line, which you cannot see it clearly, and this one is, so axis line is different, hidden line is different. Similarly, E to F or A to B, let us say first of all A to B. Whether A to B is clearly visible? No, it is not visible. So it will be hidden dash 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 dash. B to C, hidden. A to F, hidden. E to F, since E is continuous, whatever is connected to E, that will always be continuous. So E to F will be continuous. C to 3, if 3 is continuous or 3 is clearly visible, any point which is connected to 3 will always be continuous. So C to 3, continuous. 6 to F will be continuous. Next, A to E, A to E, dash 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 dash. B to D, B to D, dash 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 dash. And what about C to F? C to F is your what? Axis line. So dash will be C to F. C to F. Dash dot dash dot dash dot dash dot dash dot dash. 1 to A, 1 to A, continuous. 2 to B, continuous. So it will be something like this, or we can say if A to E. So since E is clearly visible, so whether we can join A to E like this. So what we can do, up to here we can say it is continuous and rest will be hidden. Similarly, B to D. So B is continuous, no. So it will be like, or you can say, you can do one thing, you keep this as hidden only. That is dash 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 dash. C to D, C to D. So C to D should be hidden, but since it is the outer periphery, means you are closing the solid. So let us do it as continuous. So when you will draw to the scale, you will get a figure like this. So by this you should now be in a position to understand the concept of your continuous and hidden. So I am stopping here. So now I'll take the next problem, that is your pyramid. So this was your prism. Similarly, you can have your hexagonal, pentagonal prism, you can have your square prism, you can have your triangular prism, but whenever the shape will be circle, then it will be called as a cylinder. So the concept is same. The points which are nearer to xy, they will be hidden. The points which are far away from xy, they will be continuous. If a continuous point overlaps or superimposes a hidden point, it will always be continuous. So you have to remember these things. And number 3, axis line has to be shown dash dot dash dot dash dot, and hidden line dash 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 dash. Another important point, if the point is, as per the logic, you are seeing it as hidden, but if it is the outer boundary or the outer periphery, you have to close the solid, so it will be a continuous. So you can practice this question and if required you can discuss with me. Similarly, you can try similar options in case of your pentagonal prism, square prism, triangular prism, and so on. So I am stopping this video. Thank you.